Man here for Chapter 11, Day 3 of the chi-square test for independence. All right, so here's a couple more prompts. I highlighted the totals so you don't get them confused with the table. And in parentheses, although I missed one here, in parentheses is the expected values, which we'll remind you how to do it, and then we'll do it on Desmos as well. So the question is, do different age group, we got Gen Z, which is, you know, kids born in the 19 whatever, 2010 or whatever. Millennials, Gen X, that's me, Gen X, Gen X forever. Okay, so anyhow, and then what we prefer from our how to get, news. You can imagine Gen X is probably going to be more leaning toward television and print media, and Gen Z is going to be more social media for their news. You can see it coming. Okay. So RHO is just kind of use the question. Usually it's the no association stuff. So HO, there is no association between age group and news source. And HAs, there is an association. If there is an association, it'll be vastly different. That's why that's worded that way. Okay, conditions, the same old thing, the SPIN acronym. Assume this is a representative sample. The population's got to be bigger than 6,000, which is 10 times this number right here. All news choices are independent, and all the expected's got to be bigger than 5, and they are. They're all bigger than 5. Okay. Technically, 80% got to be bigger than 5, so that would be at least 8 out of 9. So they're all of the 9. There's 9 cells. So, and they're all bigger than 5 though. Okay. Now let's run the test. The test is going to come out a really small p-value. Remember, this thing is skewed to the right. The degrees of freedom is 4 because it is row minus 1 times column minus 1. And both the rows and the columns have 3 items. So it's 3 minus 1 times 3 minus 1. That's how you get 4. 2 times 2. Let's go ahead and bring in Desmos at this time. And let's run this test. Make sure you know how to do it. You're, of course, going to type in the word inference. And you're going to go chi-square test for independence. And let's see, I got to find the data here. Give me a second. Here we go. Okay, so here's the data. 150, 100, 50, and then group 2 is 30, um, 70, 100, and then group 3 is 20, 30, and 50. Okay. I'll click on create test. Let's do the expected values. So I'm going to put the totals in here. So remember how to get these totals. For this one right here, this 151, let me annotate this a little bit. So for this one right here, what you do is you take 300, you multiply by 200, and then you divide by 600. That's how you do that. Okay. I'll do another one here. For this one right here, we do 200 times 200, which is 4,000 or whatever, divide by 600, and you're going to get this number right here. Okay. So that's how you get the expecteds on there. As you can tell, the expecteds in this case are the average of the three numbers. Is what's going on in this particular case. So anyhow, then go ahead and run the test itself, and there you have it. The p-value is very low, so we would write the p-value is low, so that would go. We would write it right here. We would write p-value is less than 0.0001. We'd circle it, and this, of course, is going to be a reject on that. Okay, so let me get that out of the way. Okay, let's go back to this. So that's why we have The p-value is low, reject HO at alpha oh 05. We have significant evidence to suggest that there is an association between age group and news source. Pretty cool. Pretty easy, huh? All right, 3B. And this was all the stuff from day one anyways, is the three brands had the same relief. So there is no association between brand and pain relief in HA. There is an association between brand and pain relief. Once again, I wrote the expected values in parentheses. That's customary. I have the totals highlighted just so you don't confuse them with the rest of the table. The conditions, same old thing, assume a representative sample. The population's got to be greater than 3,000. All relief and brand choice are independent. And I forgot to write, I should write that right here because I forgot. Okay. All, it's hard to write with a mouse, all expected, EC, this is awful, T, all expected greater than 5. Okay. As you can see, all the expecteds right here, all these numbers are greater than 5. All right. So get that written out as well. Okay. Now let's go ahead and run this test. Let me bring back in Desmos on this one as well. I'll clear this. I'll type in inference. And this is an independence test because it's a table. And let me get that data. So this is 60, 45, 30. Group 2 is 25, 40, 50. Group 3 is 15, 15, and 20. Let's create the test. Let's get the observed and expected. Let's get the totals so you can kind of see them. There we go. And let's run that test. So this one, let me move this bar here. So this p-value comes out 0.0007. Again, it's reject HO. The chi-square sum is fairly high. And again, the expected values, I showed you how to do that before. So you're going to want to write all that out. So let me go back to the notes. Here they are. So the degrees of freedom is 4. Chi-square term is 19.26. Circle the p-value, and that's a reject. We have significant evidence to suggest that the brands differ in relief. They are definitely different. Okay. So that is pretty easy. That's day 3 of chapter 11, chi-square test for independence. All right. Go get him, Stat Nation.